Welcome back to Lecture 5. In this third segment, we're going to spend a little bit more time on predicates, and we're going to consider several kinds of predicates. The first kind is the one we've already seen. It's called a unary predicate or a one-place predicate. That's a predicate that has only one variable. In this case, the predicate denotes an object property, like being a dolphin. So that will be our first example. Remember the predicate d of x from the previous segment, where d is the predicate, x is the variable. And if we state d of x, then we mean that x is a dolphin. Here's another example of a unary predicate, m of y, which we're going to need in our running example. So let's say m is the predicate is a mammal. So m of y is the propositional function that when you give it an object, it returns the proposition whatever that object is a mammal, which is true or false. Notice how in each case the variable is really a dummy variable, so you can call it x, y, or any name you want. And a third unary predicate we're going to need in our running example is the predicate being a female. So let's call it f. So f is another unary predicate with only one variable. And f of x is the propositional function that, given an object, returns the proposition that says this object is female. Notice how we use the same variable name for f as we did for d. Again, these variable names are dummy names, like in programming languages. You can call your function arguments anything you want. They are just local to that function. And similarly here, you can call the subjects of the predicates when they are variables, whatever variable name you want. So you can use the same variable names for two different predicates, or you can use two different variable names like x and y. All of the predicates we have considered so far are unary predicates. That is, they only take one variable, which means those predicates denote a property of the object that you pass in as the value for the variable. So when you pass in a specific object for x in d of x, what you get is a proposition that's either true or false that states x as the particular property that d denotes. But there are other kinds of predicates. In particular, we'll be interested in so-called binary predicates or two-place predicates. These are predicates that take two variables. So instead of denoting an object property, these binary predicates will denote a relationship between two objects. So let's consider a couple examples. First, let's consider the binary predicate g with two variables g of x, y. In other words, g of x, y is a propositional function that when you give two specific values for x and y, you get a proposition that says g of x, y is true. So let's take an example for the meaning of the predicate g. Let's say g denotes the relationship between x and y that states that x is strictly greater than y. So when we define a new predicate like g, we actually have to specify two things. Not only the meaning of it, what relationship it denotes, in this case greater than, but also the set of possible values that are acceptable to be put in for x and y. So in other words, what kind of values are acceptable in the predicate g? Well, we expect them to be numbers. If g means greater than, then we typically expect to be comparing numbers. So let's say x and y are supposed to be any real number, or maybe they should only be integers. So you see that you have to be specific about the meaning of the predicates, not only the relationship, or in the first kind of predicate, the property that they denote, but also the kind of values that they apply to. So we need a new definition here. we say that the set of values that are acceptable for x and y in g of xy is called the domain or the universe of discourse. So in this example, the domain or universe of discourse for the variables x and y in g are, say, integers. Now let's consider a second example of binary predicate, father of u and v. Now in this case, we chose as the name of a predicate a whole word instead of one letter. So most likely the meaning or the relationship of the predicate is u is the father of v. Just to show you that you can be more explicit in the name of the predicate, just make sure that you specify the order. In other words, is u the father of v or vice versa? Now that we have a predicate and we know what relationship it denotes, we still need to define the domain or the universe of discourse for the variables in this predicate. So what is the domain or universe of discourse for u and v in father of uv? Well, most likely the domain is not the set of integers, okay, because an integer is very rarely the father of another integer. So let's choose as the domain in this case the set of all people. Okay, so if u is replaced with the person David and v is replaced with the person Ben, then the predicate or the proposition we obtain is father David Ben, which means or denotes the relationship that David is the father of Ben, which happens to be true. But if you replace v with the person called Judy and u remains David, then the predicate father David Judy is false because David doesn't have any children named Judy. So I hope you're comfortable with the concept of a predicate, the concept of a propositional function, the concept of a proposition, which you get by taking a propositional function and fixing specific values for the variables in the function, and then the domain of those variables or the universe of discourse. So let me emphasize again that a predicate is not fully defined until you know its domain or universe of discourse for its variables. That's very important for another reason, which is that if you assign a value to a variable that's outside of its domain, then what you get is not a proposition. You're getting nonsense. Here is what I mean. Suppose that you decide to assign the value 1 to the variable u here, and the integer value 2 to the variable v. What you get is the quote-unquote proposition father 1, 2. And you might be inclined to say, well, this is false because 1 is not the father of 2. But actually, that's not a proposition at all. It's just nonsense because 1 and 2 are not in the domain of u and v. Therefore, you're not allowed to assign those values to u and v. And father 1, 2 doesn't mean anything. It's not false. It's nonsensical. So just remember the importance of the domain. And remember that every predicate is associated with a propositional function with one or more variables. And the point is that every variable must have a domain, even for unary predicates. So let's go back to an example of a unary predicate, say the predicate M here, which stood for mammal. So let's ask ourselves, what is the domain or universe of discourse for the variable y in M of y? Well, typically there are many ways to define the domain of a variable. Some of them are better than others. So I urge you to stop the video now and think about what would be a natural domain or universe of discourse for the variable y in M of y. So So there are several acceptable answers here. One natural answer would be to choose as domain of Y the set of all animals. That way, whenever you pick a particular animal from that set and you assign it as a value to Y, you get the proposition that this particular animal is a mammal, which is either true or false. Now, some of you may have chosen as the domain of Y the set of all mammals. And I want you to realize that this is not such a good choice. And the reason for that is because every element of that set, by definition, is a mammal. For any element you pick to assign to Y, you will always get a true proposition. In other words, the predicate will always be true. So it's not a very useful predicate to distinguish among a set of objects, since it's always true for every possible element of the domain of its variable. So the important point here is to realize that the domain that we're talking about is not the domain of the predicate. It's not the set of all mammals. It's the domain of the variable of the predicate. And typically it will make sense to pick a domain for which some of the objects do have the property associated with the predicate and some of the objects in the domain do not. That's why it makes sense to choose the set of all animals as the domain for Y. But choosing the set of all mammals, I think, is a misconception about what the domain should be. The domain is not necessarily identical and shouldn't be identical to whatever the meaning of the predicate here, in this case, mammal. It's usually a larger set of elements, some of which should have the property and some of which do not. So now that we know what the universe of discourse is and why it's important, let's go back to considering different kinds of predicates, beyond the unary predicates and the binary predicates we just discussed. Well, you guessed it, a third kind of a predicate is a three-place or ternary predicate. That is a predicate with exactly three variables. Such predicates denote a relationship among three objects. So let's consider an example here, the predicate E of P, C, and S. Let's say E denotes the relationship of being enrolled. So the meaning of E of P, C, S is that P is enrolled in course C during semester S. So the first thing to remember right away is to define the domain of the variable. So let's say the domain of P is the set of all people. The domain of C is the set of all courses at UW, say, and S is the set of all semesters, starting, for example, in the spring semester of 1970 all the way to the present. So please notice here how the domain or universe of discourse is different for each of the variables. That's a pretty typical state of affairs that we didn't see in the previous examples. And the second point I want to make is that notice how the name of the variables I chose was not random. I chose P because it's the first letter of the word person, which is an easy way to remember the domain for the variable. I chose C as the first letter of course and S as the first letter of S. Of course, these are dummy variables, so you can call them whatever you want. So it's a good idea to pick variable names that help you remember the domain of the corresponding variables. To wrap up this segment, let me mention that you could always have more variables in a predicate. So you could have 4-place predicates, 5-place predicates, and in general, we call predicates with n variables n-place predicates, or Unary predicates. Now, of course, the larger the number of variables, the more complicated the relationship among these objects the predicate denotes. So the most common kind of predicates will be unary, binary, and maybe ternary predicates. Also, before we conclude, please remember the importance of defining not only the meaning of the predicate, but also the domain or universe of discourse for each and every one of the variables associated with the predicate.